Hey everyone, today I have modified this JavaScript engine to remove closure and lexical scoping from JavaScript. Take a look at this example. Here you have a function getApple which prints the value of apple within it and then it modifies apple to 1 to 3. Now we call getApple in two different block scopes with their own local value of apple. Now normally with lexical scope it just prints green apple and 1 to 3. Because getApple tries to access the value of apple within its lexical scope, which is the global scope, and initially the value of apple is green apple, and then in the second time, it gets modified to the value 1 to 3, and that's what it prints. This makes sense. But look at what happens when I enable this feature called dynamic scope. Now it prints red apple and coconut. So if you look at the example again, now it's not even trying to access the lexical value of apple. Instead, it simply looks up within its own call stack or the caller scope or the dynamic scope and prints the local value of apple within it. So in the first case, apple is defined as red apple, and in the second case, it's defined as coconut, and that's exactly what it prints. This is known as dynamic scope, the alternate to lexical scoping. And this was just a one-liner change in this JavaScript engine called Engine 262. So today we're going to look at four things. First, in typical Bender rules fashion, we're going to look at how closure and lexical scoping is defined in the specification. Second, we're going to look at some languages with dynamic scoping like Perl. Third, we're going to modify Engine 262 to add these dynamic scoping features so that we can play with some examples. And finally, we'll look at some example of lexical versus dynamic scoping and see why dynamic scoping has some specific use cases, but in most cases, all major languages use lexical scoping to help us write reliable and performant functions. So what is a closure? Closure is simply the implementation detail of functions having lexical scoping. What is a lexical scope? So in this example, when getApple is called, it creates a new function scope. Now this function scope needs a parent scope. So at this point, JavaScript has two choices. It can either set the green scope or the red scope as the parent scope. What is the green scope? So the green scope is the lexical scope, or where the function is originally defined. And what is the red scope? Red scope is the dynamic scope or the call stack, that is where the function is getting called from. Now JavaScript, just like most languages, chooses the first option and sets the lexical scope as the parent. Now, how does it affect anything? So when getApple tries to access the variable apple, it first looks up in its own function scope. Because it doesn't find it there, it has to now look up in its parent. Because the green scope or the lexical scope is the parent, it looks up there and prints that apple is green apple. But in some languages like Perl and MATLAB, it actually has optional dynamic scoping. So in those cases, it would have looked up in the red scope and printed apple is red apple. So before we look into the specification, I wanted to share this actual experience. So this was 2018. I was interviewing at Postman. It was a telephonic JavaScript round, and they asked me why are closures important, along with the sample code. Now this code didn't really look like the typical closure example that I've seen. I think you might have also seen it in a lot of places, right? A lot of videos and blogs where it's about a function returning a function and having access to the private variables, right? This code example was pretty different from that. I only knew it as this interview question, right? So I just looked at this code, thought about it a little bit, and then answered it's going to print red apple. Yeah, I did get rejected just after that, but it motivated me to look into what lexical scoping really means, and to understand that, I need to understand what the alternate is, right? If not lexical scoping, what do we have? Now I have opened the Ecmascript specification and the relevant sections within that. So this happens in two phases. The first phase is when the function is getting defined or created, and then when the function is getting called. So this is an abstract operation ordinary function create, which gets called when the function is getting defined, right? So we are interested in this single line here. Look at line 13. It sets the f.environment to env. So f is the function here, and we're setting the variable environment to env. Env is the current call stack. So if you think about it, the current call stack when the function is getting defined is exactly the same as the lexical scope, right? So it stores a reference to the lexical scope when the function is getting created in this variable called f.environment. Again, this is an internal variable, so you will not have access to it in normal JavaScript. Now, this will get used when the function is getting called. So let's look at that. This is a method called new function environment. Now, new function environment will get called when the function is getting called. When the function is getting called, it creates a new function scope, right? So that's what this is doing. Now, again, we are interested in this single line here. So it's creating a new function environment record, which is basically the function scope, but it has to set a parent for this function scope, right? And this is what it does. So normally when you create a new scope, you set its parent to the current call stack, right? Current call stack is the scope before this new scope is created. But it doesn't do that. Look at what it does. It says set env.outerEnvironment to f.environment. So it's using the stored lexical scope, which is stored in the previous step, and sets that as the outer environment or the parent of the function scope. So this is how it's changing the function scope chain to make sure that the lookup always happens in the lexical scope instead of the dynamic scope. So I have ported the same getApple example to Perl, and I want to show you how Perl has both lexical scoping as well as dynamic scoping depending on how you define the variable. So here I have two variables, local apple and my apple 2. So whenever you use a local keyword, that specific variable has dynamic scoping. But whichever variables use my keyword, they have lexical scoping. So now when I run this example, apple is going to be red apple, which is the dynamic scoping behavior, but apple 2 has lexical scoping behavior, so it prints green apple. So now in the next step, we are going to move to Engine 262 and see if we can implement both these behaviors within JavaScript. Now we are within the Engine 262 code base. So Engine 262 is a JavaScript engine written in JavaScript, and it tries to mimic the Ecmascript specification. So let's look at the function here. It's called ordinary function create, which is same as the abstract operation that you saw in the specification. Now notice what it does here. It sets the function or the f.environment to the current scope or the lexical scope. So if you notice, it is written in a way very similar to how things are defined in the specification. Now what does this do? So when we create the new function scope, so if you notice, we are within function environment record, which is essentially the function scope. So it calls super with the f.environment that we had stored earlier. Okay, so what does super do? So it goes within the super class, which is declarative environment record, which is again a subclass of environment record. Now within environment record in the constructor, it sets the outer env to the lexical scope that we just passed in. Okay, so it's creating a new function scope and it's setting the outer environment to the lexical scope. So how do we modify this code so that the behavior changes from lexical scope to dynamic scope? So all you need to do is change f.environment with this. So what you're passing in right now is surrounding agent.running execution context.lexical environment, which is essentially the current block scope or the current scope in the call stack, right? So replace the lexical scope with the current caller scope. So as we had discussed earlier, doing this will enable dynamic scoping. Now let's get back to the Engine 262 website to see the change in action. I have used the example from the Perl code where you have apple and apple 2. So by default, it's printing green apple in both the cases because it's using the lexical scope. And if I enable dynamic scope, it's going to print red apple in both the cases. But I have also introduced one more feature called local underscore variable. Let's see that in action. So I'll disable dynamic scope and enable local underscore. So there is no change right now. But what you can do is instead of accessing Apple directly, we can do local underscore Apple. If you do that, it's going to show us a similar behavior to what you saw in the Perl local keyword. So when you're doing local underscore Apple, only Apple get replaced with the value from the dynamic scope. So Apple is getting the value red apple from this scope. Similarly, I can replace both of them and both of them are going to get the value from the dynamic scope. So I'm able to choose whether to access a variable from the lexical scope or the dynamic scope. I'll share a link to the GitHub code for this change if you want to see how this is done. Now let's look at 3 examples of lexical scope versus dynamic scope with some real life use cases. Okay, here's the first one. It's about callbacks. Take a look at this part of the code. This is a very common use case where you have something like a fetch data which returns some data asynchronously, and then you want to do something with the data, so you schedule a set timeout and pass in a callback function which tries to access the data. Now this will work perfectly with lexical scope because the function has access to data from its outer lexical scope here. But this will break completely if you have dynamic scoping, because this callback function does not have access to data from its own call stack. And because the function will get called by set timeout, you don't even have any control over when it's going to get called or what the call stack is going to look like or what arguments are going to get passed in. Okay, so let's look at that same code with this slightly more contrived implementation here. So right now we have lexical scope, and you have get apple which is trying to access this apple, and if we run this, it's going to print green apple with the lexical scope. But if we enable dynamic scope, this is going to break because apple is not defined in the call stack. Okay, we don't have again any control over how callback is going to call it, so we cannot prepare the call stack properly even if we wanted to. So what I thought is that if we only had dynamic scoping, can you still implement it in such a way that it gives the same behavior as a lexical scoping, right? Can you still make it work with dynamic scope? So here is a modified version of that same code. Okay, so you only changed 2 things here. Here's the first part. So instead of accessing apple from the outer scope, now the function takes in an argument called apple and it tries to print that. So we are trying to access the argument, right? But again, we don't have any control over how the argument is going to get passed in from the callback. That's why instead of passing in this normal function, we have turned it into a bound function, and we bound it with the value of apple from this scope, which is the green apple. Okay, so we created a bound version of this function where this value of this argument apple is going to get set to green apple whenever it gets called. So now if you see, we have dynamic scope enabled and this is still working perfectly even though it gets passed to this callback function. But this is not a direct replacement for how private variables and closures work in the lexical scope. So I'll show you why. I'll go back to the previous example with lexical scope and I'll make a small change. See here, if you see, after doing console log apple, it's setting apple to 1 to 3, and now we are calling callback twice, right? So what happens with lexical scope is that first time it prints green apple, but then the apple variable in the lexical scope gets modified to 1 to 3, so that's what it prints in the second call. Okay, so this is how it behaves with lexical scope, and this is how we normally use private variables. But if I move to dynamic scope with the bound function example and we do the same thing, then look at the output. Instead of printing green apple and 1 to 3, it just prints green apple every time. Why is that? Because of how bound functions work, right? It doesn't actually create the outer scope. It doesn't have access to the variable reference, right? But what happens is every time this function will get called, it will create a new variable apple which is the argument, and assign it to the value that we stored here, which is green apple. So every time this function is called, it creates a new variable apple where the value is green apple. So even if we modify it, it's not going to persist in the next function call. So that's why we can't really use it as a private variable, even with the bound function in case of dynamic scope. The second example is about passing in configurations to nested function calls or nested components. Think of something like a theme or a global config that has to get consumed in a lot of different functions, a lot of different files. Now, with lexical scoping, what we would normally do is we'd have to pass in the config to all the different function calls. So what I mean is, let's say you start with a main, which needs a config, which calls a function 1, and main needs to forward the same config to function 1, which again needs to forward the same value to config 2, so that all of them are able to actually access this value. Okay, and if you see here, after we get the config, we have to pass the same value to config, and that's how it works in case of lexical scoping. But this is actually an advantage if you have dynamic scoping. It gets much simpler when you have dynamic scoping enabled. Here is the modified code for dynamic scoping. Notice here, function 1, function 2, main, all of them don't need config to be passed in explicitly or forwarded to the next level. As long as we have config in the call stack, so if you see here, we have config in the dynamic scope, as long as that is present, the main as well as the nested function calls will have access to this config from the outer dynamic scope. So this removes a lot of boilerplate code for this particular use case. As I mentioned about components, so this dynamic scoping example is also very similar to what you can do in React with context, right? So let's say in React, we have a my app where you create a context provider and then you have form within it. Now, if form has input and button or other subcomponents within it, all of them can access context directly without having to pass in the argument explicitly for all the nested components. This is the third example. This is about refactoring. So with lexical scope, refactoring the functions is much easier. So let's say we have getApple here, which tries to access from the outer lexical scope. And right now it's working fine. And if you want to rename Apple to Apple 2, all we have to do is look in its lexical scope or in that same file where it is getting exported, let's say, and change the value there. But in case of dynamic scope, you have to look in all the files where this is getting imported and figure out how the call stack looks like when this function gets triggered and try to modify the variable name in that call stack, which can be a lot of headache. So if I enable dynamic scoping, initially it's broken. Now let's say this gets imported in file 1 where Apple might be defined somewhere and we have to rename that to Apple 2. And then again we have file 2 where maybe this is calling a callback function like on something and passing in getApple. In that case, you need to figure out how on something works and modify the variable name there as well. So this is simple in this small example, but this can get a lot more complicated when you actually have different files calling each other. Thanks for sticking so long during this video. I had a lot of fun making this Engine 262 mods to actually see the dynamic scoping in action, and I hope you liked it as well. Also, a little bit of update, I'm trying to be a bit more consistent on YouTube. I know it's been a long time since I made the last video, but I'm also trying to make shorter form videos now, especially focusing on interview experiences and other topics. And please subscribe, I actually mean it. I'm just trying to reach 1,000 subscribers right now, so that would be very helpful. And yeah, stay along for the journey. Thank you.